Okay, today we're looking at multiplication and division, complex numbers. First of all, multiplying. Okay, so multiplying, really we're just using the things that we already know about expanding brackets and that sort of thing. So if we've got two complex numbers, Z1 is A plus BI and Z2 is C plus DI. And if we wanted to do Z1 times Z2, we'd simply need to multiply those two things together. So A plus BI, C plus DI. In brackets, just looks like, binomial expansion, which you would do in quadratics or whatever. So you get AC plus ADI plus BCI plus BDI squared. So I squared, of course, is -1, so you get AC minus BD for the real part, and for the imaginary part, AD plus BCI in general terms. So if we want to look at a couple of quick examples of that. So first of all, we're going to be asked to simplify some things. Okay, so first one is 2i bracket 2 minus 3i. So yeah, that's just simply 2i times 2, 4i. 2i times negative 3i, so that's negative 6i squared. So 4i, I squared is 1. So 1 and that negative 1 and the negative there is a plus, so plus 6. So normally, of course, we write the real part first, so if we're going to be real super technical like we should be, and precise, we end up with 6 plus 4i. Okay, so that's that one. The next one we might look at is 2 minus 3i minus 3 plus 4i. So just a binomial expansion. 2 times negative 3 is negative 6. 2 times 4i is 8i. Negative 3i times negative 3, negative, positive. 3 3s are 9i. And negative 3i times 4i is negative 3 4s are 12. I times I is I squared. I squared, of course, is negative 1, so we end up with plus 12 on the end, negative 6 in front here. Let's combine those I parts. So we've got 8i plus 9i is 17i, and now, of course, our real parts. And so we'll end up with 6 plus 17i for the answer to that. Okay, so just got to remember about this bit here, that the I squared part, the I squared is negative 1. Alright, now before we move on to division, we look at the conjugate. Of a complex number. Okay, so conjugate is very simple, very similar idea as, let's get rid of that last line, shouldn't have that. Very similar to conjugates in surds. So if we've got Z equals A plus BI, then the conjugate Z with the bar across the top is A minus bi. So, very simple. Now, the thing about a conjugate, and its conjugate, and so let's have a look at, say Z1, 1Z equals, say 2 plus 3i, then Z conjugate will of course be 2 minus 3i, and if we do Z by its conjugate, two plus 3i, 2 minus 3i, we get 2 2s are 4, minus 6i, plus 6i, minus 9i squared. These two, of course, cancel. This bit here becomes plus 9, and we've got 4 plus 9 is 13, a real number. So the conjugates, when you multiply something by its conjugate, you end up with a real number. Alright, so let's have a look at a couple of examples. So if Z1 equals 2 plus 3i, and Z2 is minus 4 minus 5i, then there's a whole bunch of different things that we can do. So let's find a few different things. So let's look at Z1 conjugate plus the Z2 conjugate. Okay, so not too hard. 2 minus 3i would be Z1 conjugate. Remember, we just changed the sign of that imaginary part. Plus negative 4 plus 5i. And so at our real imaginary part, so 2 plus negative 4 is negative 2. And then we've got negative 3i plus 5 plus positive 5, so that's plus 2i. Okay, so plus 2i, and there's simply our answer. Now, that of course is different to Z1 plus Z2, the conjugate of. So this time what we need to do is we need to do Z1 plus Z2, and of course that is 2 minus 4 minus 2. 3i minus 5i is minus 2i. And the conjugate of that then is minus 2 plus 2i. Okay. Alright, so the answer may be the same, but the thinking and the process of the order that we're doing things is different. Okay, so it may not necessarily always be the same. Okay, so that's conjugates. Now, what do we really need to do conjugates about? Conjugates we really need to be looking at is when we're doing division of complex numbers. Okay, so if we have Z1 divided by Z2, so let's have a look at here. Z1 equals 4 minus I, and Z2 is 3 plus 2i, for example, and we want to find Z1 divided by Z2, then what we'll have is 4 minus I over 3 plus 2i, so we end end up with that. Now, mathematicians don't like that, just like they don't like unrationalised denominators, so we need to then multiply top and bottom by the conjugate of what is on the denominator. Okay, that will then give us, on our numerator, 12 minus 8i minus 3i plus 2i squared. On the numerator, it will give us 9 minus 6i plus 6i minus 4i squared. Minus 6i and the plus 6i on the denominator, of course, cancel. On our numerators, there we end up with minus 2 for that. Our denominator here, we end up with plus 4 for that. Okay, so we end up with 12 minus 2 is 10 on the top, minus 8 minus another 3 is minus 11i, and on the bottom, 9 plus 4 is 13 for our final answer. Okay. Okay, so if we have something like, say, 3 minus 4i over 3i, then we have to turn the denominator into a real number, so conjugate in this case is just minus 3i. And top then is that, and the bottom is minus 9i squared. So we'll have minus 12 minus 9i on the numerator, and on our denominator we'll just have 9 for that. And of course we can, in this case, if we wish to, which we of course should, cancel things down. And in this case, 3 will go into, or 3 minus 3 can come out as a common factor up the top, giving us 4 plus 3i. And underneath the 9, of course, 3's will cancel. Alright, now if we really strictly want to express our answer in real and imaginary parts, then we should really split it up. And so we should really say that our real part is minus 4/3, and our imaginary part is minus, in this case, I. Alright, so that is pretty much it in a nutshell. So that then brings us up to exercise 1E. So that's question set number 5 on your notes.